Welcome, welcome, welcome to the Energy Sketch. I'm Michael Johnson. Okay, welcome to the whiteboard, folks. Today we're going to talk about this research paper I came across recently. Imagining sustainable human ecosystems with power to X, in situ resource utilization technology. So that's a lot of words, but essentially it means how do we live in a remote area like another planet, and they use the examples of the moon and Mars, and I'll talk about Mars today. And how do we live on that planet using only the resources that we have available in situ? And I find this kind of neat. It's futuristic. If you read a lot of sci-fi books, there's various ways that they use in situ resources to build cities and huge complexes on other planets. And also, a lot of the technology that's needed to achieve this is also needed to help support the transition to a global decarbonized energy system here on Earth. So it's not just dudes going off in a rocket to Mars to have fun on a playground. It's really thinking about these in situ resource utilization technologies and developing them because they are also very important for our life here on planet Earth. So let's think about living on another planet like Mars and what are the basic building blocks that you need in order to survive in that environment. And the basic needs are a life support system, so that would include oxygen, nitrogen in a breathable atmosphere, along with water, food, of course, agriculture. I won't really talk about that in this episode. We could talk about it in a future episode, but for that, you'd need essentially nitrogen fixation and fertilizer production. Then there's the propellants and energy storage that you would need to travel on the surface of the planet and also to get off planet and back to the orbiting systems or back home to Earth. And finally, you need manufacturing to build all the machines and all the living quarters, and that includes like metals as well as plastics. So those are the essential building blocks that we need to build up. And what are the resources that we have at our disposal in situ? Again, well, we have the sun shining down on the planet, and we have the atmosphere of the planet. In the case of Mars, it's primarily 95% or so CO2, but also nitrogen, a bit of argon, a bit of water vapor also. Then there's the rocks, the Martian regolith, which is made up of mostly metal oxides like silicon, iron, aluminum, calcium, magnesium, titanium, and a bunch of others. And it depends on where you are on the surface of the planet. There are different mixes of that. And then there's the water, and water is present on Mars as ice and also as mineral hydrates within the Martian regolith. So the first thing that we'll need is some power to power all of this machinery and equipment that we need. And for that, we would install either solar panels or perhaps some sort of small compact nuclear reactor. And then there are three essential electrolysis processes that we call more generally power to X, which means we're using electrical power to drive some electrical, chemical, or physical processes that are going to convert all of the available resources we have on the planet, those in situ resources. We are going to use power to X technologies, primarily electrolysis, to convert them into the appropriate building blocks that we need. So let's take a look at these three electrolysis processes that we'll be using. The first one is molten oxide electrolysis. So taking those metal oxides, and we do this already on Earth today, particularly for metals like aluminum or zinc. We power those processes with electricity, and they chemically convert the metal oxides into pure metals, and the byproduct of those would then also be oxygen. So the metals we can use as a material for manufacturing, and the oxygen we can use in our life support systems. The second electrolysis process here is a standard water electrolysis, where we would start by melting the ice that's available on the planet into water, and then use an electrolysis process to split that water into hydrogen and oxygen. And the hydrogen could be used as our propellant, or it can be used later for further chemical processing. And the oxygen, again, goes into our life support system. Then the third electrolysis process is a kind of combined CO2 and water co-electrolysis, which would produce syngas, so that's a mixture of CO, carbon monoxide, and hydrogen, along with oxygen. So again, the oxygen go into our life support system, and the syngas, this mixture of CO and hydrogen, is a feedstock for further chemical processing, whereby we can combine that with additional hydrogen to hydrogenate the CO and create methane, which can be used as a propellant, and also methanol, which can be used also for energy storage, but can also be used as a feedstock to eventually make plastics, which are the other element that we need for our building materials. So now we have metals and plastics that we can 3D print on site in order to produce all of the machines and structures that we need. And we have all the other elements we need for our life support system and our propellant. Only thing missing is the agriculture, but basically what we need there is nitrogen fixation, and there are small amounts of nitrogen available in the Martian atmosphere, and we could use some plasma processes in order to fixate and capture those nitrogen molecules and put them into fertilizers to power our agriculture. So this is a sort of idea of the types of technologies that we would need to exist using in situ resources on another planet, like Mars in this example, but also an interesting look into how those technologies are also the same technologies that we need here on Earth in order to succeed the energy transition towards a decarbonized global energy system. And I'll go into more details in a future episode about details of those technologies and the technology status and the costs and the scale and all of these things in another episode. But for now, thank you so much for tuning in to the Energy Sketch. Wish you a good week, and don't forget to hit subscribe and tune in next week, Mondays at 12:12 p.m. on youtube.com/@Energy Sketch. See you later. Toodaloo.